Hello viewers, it's good to have you back. Still discussing geometry, and in this session I'll be discussing the polygon. Alright, on the screen you can see that the polygon is any closed figure which is bounded by at least 3 straight lines. If these lines are 3, we call it the triangle. It can be more than, that's why we're saying at least 3. At least. We don't have a two-sided polygon. We don't have a one-sided polygon. It has to be at least 3 straight lines, which of course is now called the triangle. So a polygon is just a closed shape, that is, all the sides are closed together. There is no open side that is left. So a polygon is any closed figure which is bounded by at least 3 straight lines. And on the next screen you can see that polygons are named according to the number of sides they possess. Polygons are named according to the number of sides they possess. Now a 3-sided polygon of course is the triangle, which we just discussed in the previous video. A 4-sided polygon is called the quadrilateral. That's a 4-sided polygon. A 5-sided polygon is called the pentagon. 6-sided is called the hexagon. 7-sided is called the heptagon. 8-sided is called the octagon. 9-sided is the nonagon, and of course the 10-sided polygon is called the decagon. 11 is ondecagon, 12 is dodecagon, and the rest of them. Alright, but our interest is just on 3-sided triangle, 4-sided quadrilateral, 5-sided is pentagon, 6-sided is hexagon, 7 is heptagon, of course 8 is the octagon, 9 is the nonagon, and 10 is the decagon. Straight away we go to the theorems. There are 2 theorems that are always used as far as solving problems with polygons are concerned. 2 theorems are very important and very ideal. On the screen you can see the first theorem is used to calculate the sum of interior angles of any regular polygon. And of course the formula says that the sum of the interior angles of any polygon is given as 2n minus 4 times 90 degrees or n minus 2 times 180 degrees. It's a very important and powerful formula as far as solving mathematical exercises involving the polygons are concerned. The sum of the interior angles of a polygon is given as 2n minus 4 times 90 degrees. Let me write it so that you see. We have the formula for finding the sum of the interior angles of any regular polygon as 2n minus 4 times 90 degrees, or you say n minus 2 times 180 degrees. That means if I needed to confirm the sum of angles in a 3-sided polygon, which is called a triangle, so if I'm using this second formula, any one you use, you still have the same answer. If I'm using this second formula, n is now equals to 3, 3-sided polygon, so n is 3. So we now fix it up. We have 3 minus 2 times 180. So we have 3 minus 2 is 1 times 180. So that will give us 180 degrees. So that means the sum of interior angles of the triangle is always 180. We've said that earlier. If I needed to find out the sum of angles of the quadrilateral, which is a 4-sided polygon, so this would have given us n minus 2 times 180 is the formula, where n is now 4. 4-sided, n is now 4. So we have 4 minus 2 times 180. And 4 minus 2 will give us 2 times 180. So we have 180 times 2 giving us 360. That means the sum of angles interior of a quadrilateral, which is a 4-sided polygon, is 360 degrees. And just to show you one other example, for a 5-sided, which is pentagon, you also have n minus 2 is 5 minus 2 times 180. So we have 5 minus 2 is 3 times 180. And of course if you multiply this, you are going to have 540. This is it, 180 times 3. 3 times 0 is 0. 3 times this is 24, right? So and carry 4. 3 times 1 is 3 plus this is 4. So we have 5. We have 540 degrees as the sum of the interior angles of a pentagon. N minus 2 times 180 is the formula. If you want to find for the 10-sided polygon, 10 minus 2 will give you 8 times 180. You want to find for heptagon, which is 7-sided, 7 minus 2 is 5. 5 times 180. Those will give you the values for the sum of the interior angles of those polygons respectively. Alright, so that's the first theorem. N minus 2 times 180 or 2n minus 4 times 90 degrees as the 2 formulas we use to find the sum of the opposite angles, or the sum of the interior angles of a polygon. Now the second theorem says that The sum of the exterior angles of a polygon is 4 right angles. A right angle is equals to 90 degrees. So when we say 4 right angles, it means 4 times 90 degrees, which will give you 360 degrees. Alright, so the sum of the exterior angles of any regular polygon is 360 degrees. The sum of all the exterior angles of any regular polygon is equals to 360 degrees. Take note, if a polygon has 3 interior angles, which is a triangle, it follows that we are also going to have 3 exterior angles. When you extend, a point that was called an angle, you now have an angle outside, which is called the exterior. So if we have a 5-sided polygon, interior angles are 5, exterior angles will also be 5. If you have a 10-sided polygon, interior angles are 10, and of course exterior angles will also be 10. If you have a 7-sided polygon, interior angles are 7, and their sum is the first theorem, n minus 2 times 180, and exterior angles will also give you 7 in all, and their sum will give you 360 independent of the polygon you are talking about. That means a 10-sided polygon with 10 exterior angles, all of them added together will give you 360, meaning each of them will be 36 degrees. That's what it means, because 36 times 10 will give you the 360. Now a 7-sided polygon will also have 7 exterior angles. Adding the 7 together will give you 360. If you want to find the value for each, you just say 360 divided by 7. That will give you the value for each. Now an 8-sided polygon will have 8 interior angles and also 8 exterior angles, and adding all the 8 exterior angles together will give you 360 degrees. So even if that polygon is a 20-sided, all the 20 angles added together will give you the 360. That's the second theorem, that the sum of all the exterior angles of any polygon is 360, whereas the sum of all the interior angles of any polygon is n minus 2 times 180 degrees, or 2n minus 4 times 90 degrees. These are the 2 theorems that we are going to use as far as our polygons are concerned. And of course, in the next tutorial video, I'll be using these 2 theorems to help you evaluate a whole lot of mathematical exercises involving the polygon. Don't go anywhere.